Next is the circular motion. What is meant by circular motion? How you can define it? So first of all, if I take any object and this object is moving into the straight path, then what will happen? And if I want to move the same object into the circular path, just like this, then what I have to do? If I want to move the particle from straight path into the circular path, for that I require a force which is called the centripetal force. And this force is always responsible for the body to move into the circular path. If the object move into the circular path, it is because of the centripetal force, that there is a force which is acting on the object, which is called the centripetal force. Because of this force, the object move into the circular path. As you know that the force is a vector quantity. It has magnitude as well as direction. So what would be the direction of that force? So remember that this force is always acting towards the center of the circle. The direction of the centripetal force is always towards the center of the circle. So when any object move into the circular path, there is a force which is acting towards the center of the circle, and this force is responsible for the object moving into the circular path. This force is basically called as centripetal force. See its definition. When the object moves into the circular path, a force acts towards the center of the circle. This is very important point, that what would be the direction of the force when the object move into the circular path. So in all the ways, the direction of this force is towards the center of the circle. This is known as the centripetal force. The name of this force is centripetal force, and it is responsible for the objects to move into the circular path. So first of all, when you apply the force on the body, you know that the body accelerates. Can you define the acceleration? What is the formula for the acceleration? You know that acceleration is equals to delta v by delta t, change in velocity per change in time. According to this formula, I can simply write here delta v is change in velocity, which is v minus u over delta t. So according to this equation, I can simply say that when acceleration is produced in the body, it means that its velocity is changing. According to Newton's second law of motion, F is equals to ma. When you apply the force on any body, then the acceleration is produced in it. So how the body accelerate here? The body accelerate, it is because of the reason there is the change in velocity of the body. So I can simply say that when you apply the force on any object, then it accelerates because here the change of the velocity take place. When the object moves into the circular path, here is also force which is called the centripetal force. So if I suppose that this force is the centripetal force, then this acceleration would of course be the centripetal acceleration. Now we have to talk about the centripetal acceleration, and you also know that acceleration is a vector quantity. It means that acceleration has magnitude as well as direction. So what would be the direction of the centripetal acceleration? According to this formula, F is equals to ma. The direction of the force and acceleration, both of these are same. If I suppose that there is an object and the force is acting on this object towards right, then of course the body accelerates in the same direction. I can simply say here the direction of the acceleration and force, both of these are in the same direction. And when the body moves into the circular path, the centripetal force is towards the center of the circle. It means that the direction of the centripetal acceleration is also towards the center of the circle, which is in the direction of the centripetal force. So if I again make here the object which is moving into the circular path, the direction of the centripetal acceleration is towards the center of the circle. similar to the direction of the force. So you can see here, when the force is applied on object, it accelerates due to the change in velocity, because the acceleration is equals to change in velocity per time. So when the velocity changes, there would be the acceleration produced in the body. This acceleration is known as centripetal acceleration, and it acts in the direction of the force, which is towards the center of the circle. It means that the direction of the centripetal acceleration and centripetal force is the same. So after that, you know that acceleration is a vector quantity. It has magnitude and direction. So if I talk about the velocity of the body, because the velocity changes due to which the body accelerates. So you know that velocity is also a vector quantity, and the magnitude of velocity is basically called as speed. So how the body accelerates when it moves into the circular path? Which thing is basically changing here? So I suppose that there is object which is moving into the circular path. Then remember here, the magnitude of the velocity of the body moving into the circular path does not change. The speed remains same. It is because of the reason the speed is basically the magnitude of the velocity. So any object which is moving into the circular path, it has the same speed, but the direction of the velocity changes at each point. Due to the change in the direction of the velocity, there would be the acceleration, which is called as the centripetal acceleration. So what would be the direction of the velocity here? If I suppose that the object is at this position, then what would be the direction of the velocity at this point? Second position I consider here, at both of these positions, what would be the direction of the velocity? So remember that the direction of velocity is tangent at that point. If you want to see the direction of the velocity at this point, you just need to draw here the tangent line. Just like that. On the other side, if I have to draw here the tangent line, it looks like that. So see both of these directions. These are the direction of the velocity, and at both of these points the direction of the velocity changes. These are the direction of the velocity if you consider that the body is moving in clockwise direction. Because here the arrows shows that the body is moving in the clockwise direction. Let's see here. The speed of the object remains constant. Speed of the object is not changing because it is the magnitude of the velocity. But the direction of the velocity changes as it moves along the circular path. When the object moves into the circular path, then the direction of the velocity changes at each point. So acceleration is produced in a body either when the magnitude of velocity changes, either its direction changes, or both of these changes. In this case, the direction of the velocity is changing, due to which there is a acceleration produced in the body, which is called the centripetal acceleration. That is, a circularly moving body has a constant speed but changing velocity. So if I suppose that first of all the object is moving into the circular path, just like here, if I remove the centripetal force due to which the object is moving into the circular path, then what will happen? Of course, you know that the object move into the circular path because of the centripetal force. So if I remove the centripetal force, then what will happen? The object cannot move into the circular path. It will move into the straight path, and this straight path would be in the direction of the velocity, which is tangent to that point, just like that. So I can simply say here, if you remove the centripetal force, then the object will move tangent to the circle. The same point is given here. If the force that is providing the centripetal acceleration means that centripetal force is suddenly removed, then what will happen? The object will move on tangent to the circle. So if you remove the centripetal force, the object will move in the direction of the velocity at that point. Next, we have to see that on which factor the centripetal force depends. First of all, see here very important point. I take the object to be moving into the circular path, and you know that the force is towards the center of the circle. But the object is moving into the circular path. It means that what would be the angle between the force and the direction of the motion. So first of all, you have to draw here the tangent line to show the direction of the velocity. Here, can you tell me the angle between the force and the velocity of the body? It is 90 degree because the force is acting in downward direction and the velocity is towards right. There is an angle of 90 degree between both of these. So I can simply say that when the angle is 90 degree, then both of these are perpendicular or right angle to each other. So same point is given here. The force and the direction of motion means that the direction of the velocity, both of these are perpendicular to each other. Means that they make an angle of 90 degree or both of these are at right angle to each other. On which factor this force depends? So for that you have to understand the formula of the centripetal force. Centripetal force is represented by F and here is a small c, showing that this force is centripetal. It is equals to mv square over r. This force basically depends upon the mass, the velocity and the radius of the circle. These three factors basically determines the centripetal force. You can see here, this force depends upon the radius of the circular path, mass and the speed of the object. And the formula is given here, F is equals to mv square over r, where m is the mass of the object, v is the velocity with which the object is moving and r is the radius of the circular path. Can you tell me what would be the unit for the force? The unit of the force is Newton. And here it's the centripetal force. It doesn't matter that which type of the force is here, but the unit remains same. It means that here the unit of this force is also Newton. You can see in this figure, the force is towards the center of the circle, but the velocity is tangent at that point. Means that it is perpendicular to the force. So I can simply say that the direction of the motion and force, both of these are perpendicular to each other because they make an angle of 90 degree according to this diagram. Next are very important results that you have to derive by the formula. Here you can see the centripetal force is directly proportional to the mass if you keep the velocity and radius constant. What does this mean? It means that if you don't change the value of the velocity and the radius of the circle, then centripetal force is directly proportional to the mass. Larger the mass of the object, larger would be the centripetal force. Smaller the mass of the object, smaller would be the centripetal force. So both of these are directly proportional to each other. After that, if we want to see the relation of the force with the velocity, then F is directly proportional to v square, keeping the mass and radius constant. What does this mean? It means that you don't need to change the value of the mass and radius. Then force is directly proportional to the square of the velocity. If I suppose that I have two objects, both of these are moving into the circular path but their velocities are different. I suppose that v1 is 2 meters per second. And for the second object, v2 is equals to, I suppose it's 4 meter per second. Then for which one of the following particle the larger force is required? As the force is directly proportional to v square, it means that the particle which has larger velocity, it requires the large force to move into the circular path. So it is for the second particle v2 which is 4 meter per second. For that object, for that particle, the required force is larger. After that, I want to see the relation between the centripetal force and the radius. So the force is inversely proportional to the radius. If you keep the mass and the velocity of the object constant. What does this mean? When you have to keep the mass and the velocity constant, velocity is only constant means that the speed value does not change. So when the mass and the speed of the object remain same, the force is inversely proportional to the radius of the circle. If I take the two objects and both of these are moving into the circular path, they have different radius. Let me draw here first of all the circles. So I suppose that it's 1 and it's 2. Now see the first circle, it has a smaller radius as compared to the second one. So if I suppose that there are the particles that are moving in both of these circular paths, for which one of the following figure the larger force is required? According to the relation between the centripetal force and the radius of the circle, both of these are inversely proportional to each other. It means that larger the radius of the circle, the smaller would be the force which is required to move that into the circular path. So the second figure showing that the radius is larger, it means that here the small force is required. The first path showing that the radius is smaller and it requires the large force. Because the force and radius, both of these are inversely proportional to each other. So let's see this relation from here. A large mass requires a larger force to move by keeping the speed of the object and the radius of the circle constant. So in the first relation, basically they explain this one. The relation between the force and mass. Force is directly proportional to the mass by keeping the speed and the radius constant. Larger the mass of the body, larger would be the force which is required to move that into the circular path. A larger force is required for the object moving in a smaller circle by keeping the mass and the speed constant. So for the object which is moving into the smaller circle means that its radius is smaller. This is given by the third relation. The relationship between the force and radius. Smaller the radius means that the smaller the size of the circle, larger force will be required for the particle to move into the circular path. That's why the large force is required for the object moving into the small circle by keeping the mass and the speed constant. Fast moving object means the object which has large speed requires the large force, keeping the mass and the radius constant. So you have to keep the mass and radius constant. Then for the fast moving object, large force is required to move into the circular path. After that, there is a simulation which is related to the circular motion. It basically relates the force with different parameters. So let's see this. You can see here there is a circle and the red particle is shown here which is moving into the circular path. So first of all, let me here set up the speed values. I suppose that its value is 2.72. When I play it, you can see the object is moving into the circular path. What would be the effect on the centripetal force if I increase the speed? You can see here, I increase the speed, then play this. The object is moving into the circular path. Then actually I have to see the effect on the centripetal force. For that, first of all, I will show the direction of the centripetal force and the centripetal acceleration here. So let me show this as well. You can see here, the green arrows shows the direction of the centripetal force, while here the blue arrow showing the direction of the velocity. So let's suppose first of all the velocity is very small. Then see here, the force is also small. Now I'm going to increase the speed. Then what will happen? Accordingly, The length of the force arrow and the speed, both of these are increasing. It means that when you increase the speed of the object moving into the circular path, the centripetal force increasing, as well as the centripetal acceleration, because both of these are directed towards the center of the circle. After that, I will reset these values, and now we will see the relation between the centripetal force and radius. So first of all, suppose the radius to be very small. Then see the force. Force or acceleration, which is the centripetal acceleration, is shown by this green arrow. See the length of this arrow. I will play it. So when the radius is smaller, the centripetal force is very large. Now I'm going to increase the radius. The centripetal force decreases, means that the length of the green arrow decreases. I will play it again. You can see the body is moving into the circular path. Green arrow shows the direction of the centripetal force and acceleration, while the blue is showing the direction of the velocity. So when I increase the radius of the circle, accordingly the magnitude of the centripetal force decreases. So I can simply say that both of these are inversely proportional to each other. By increasing the radius of the circle, accordingly the centripetal force and centripetal acceleration decreases. You can practice this as well from here. Let's go back. Here is the examination tips. For a body to be moving in a circular path, the force acts in the direction of the acceleration. The direction of the centripetal force and the direction of centripetal acceleration, both of these are in the same direction, which is towards the center of the circle. And the direction of the velocity is perpendicular to its acceleration. What does this mean? Here is a circle and the object is moving into the circular path. The acceleration is towards the center of the circle. What would be the direction of the velocity here? So draw here the tangent line to show the direction of the velocity. Now see both of these. The velocity is acting in this direction and the acceleration is in this direction. Both of these making an angle of 90 degrees with each other. It means that the direction of the velocity is perpendicular to the direction of the acceleration. This is only true for the centripetal force and the centripetal acceleration, that when the object moves into the circular path, the velocity is perpendicular to the direction of the acceleration. Here is the exam question that appeared in February-March 2020. A car is driven round a bend in the road at a constant speed. So here is a car which is moving into the circular path. What is the direction of the resultant force on the car when it is going around the bend? So this car is going around the bend. What would be the direction of the resultant force? Let's see the answer. Answer A, parallel to the motion and in the same direction as the motion. Answer B, parallel to the motion and in the opposite direction to the motion. C, perpendicular to the motion and towards the inside of the bend. D, perpendicular to the motion and towards the outside of the bend. So first of all, see here, you know that when the body is moving into the circular path or when it's going around the bend, then there is a force which is acting towards the center of the circle or bend. This is called the centripetal force. Here the resultant force is basically the centripetal force. We have to tell its direction, in which direction this force is acting. So first of all, consider any object which is moving into the circular path. For that object, the force is acting towards the center of the circle. Now this car is going around the bend. Of course, the center of this bend would be here, and the direction of the resultant force is towards the center of this bend. The direction of the force would be here. This is the direction of the resultant force F. After that, you also have to tell that either this direction is parallel to the motion or perpendicular to the motion. So you can see here the direction of the motion of the car is given, which is given by this arrow. What would be the angle? Can you tell me the angle between the force and the direction of the motion of the car, which is shown by the arrows? It is of course 90 degree. It means that when the angle is 90 degree, the force and the direction of motion of the car, both of these are perpendicular to each other. Let's see the answer and explanation for that. Assume that car has the circular motion near the bend. So the resultant force will act perpendicular to the motion towards the inside of the bend, just like in the case of stone attached to the string. So when you attach a stone with the string and move it into the circular path, then of course the force is acting towards the center. Similar to that, in the case of car, the motion is perpendicular to the force and it is basically acting towards the inside of the bend. According to that, answer C is correct. Let's go back and see the answer C. In the C answer, perpendicular to the motion and towards the inside of the bend. So the force is acting inside the bend and it is perpendicular to the motion. Answer C is correct from here. Here are some questions for your practice. Let's see these. Question number 1. A body of mass 7 kg is moving with a velocity of 5 meter per second in a circle of radius 5 meter. What is the centripetal acceleration of the body? So basically you have to calculate here the centripetal acceleration when the mass, radius and the velocity of the body is given. So remember here how you can calculate the centripetal acceleration. According to the formula of centripetal force, F is equals to mv square over r. If you compare it with the Newton's second law of motion, F is equals to ma, then you can easily calculate the value of the a, which is v square over r. This is basically the formula which is used to calculate the centripetal acceleration. So you have to use this formula and find out the value of centripetal acceleration for a body that is moving into the circle of radius 5 meter. Question number 2. A rock whose mass is 650 kg is attached to the end of 1.8 meter long string and wheeled in a horizontal circle at 25 meter per second. What is the centripetal acceleration and the centripetal force of the rock? So the mass, here the mass of the rock, also the radius and the speed is given. You actually calculate here the centripetal acceleration and the centripetal force for that rock. Question number 3. A car of mass 90 kg is taking turn on circular track of radius 35 meter with a velocity of 12 meter per second. What is the magnitude and the direction of the force on the car while moving in circular track? So basically the mass, velocity and the radius of the circular track is given. You have to find out the direction of the force as well as the magnitude of it.